Everyone. This is our look at titrations. Titrations, it's a type of experiment. It's a style of experiment that we perform to determine an unknown concentration. It's like if we had a sample of water and we wanted to know what the concentration of mercury was in it. Or if we had an unlabeled acid in our lab and we wanted to figure out what its concentration was. It's a style of experiment, really narrowly defined. We use it to determine concentration of some chemical. It sets up like this. We have a piece of glassware. It's called a burette. The chemical that goes inside the burette is always called the titrant. It might be an acid, it might be a base, it could be some other kind of chemical in there, but it's always referred to as the titrant. This burette, the piece of glassware, is open at the top. It comes to a point at the bottom, which is also open, and it has a valve so we can open and close it to release the titrant or stop it from flowing. In the bottom, underneath, we might actually be using a beaker. More typically, we're using an Erlenmeyer flask, and the chemical that's in there is called the sample. Sample's in the flask. Also in the flask is an indicator. We're going to spend more time with indicators in the next unit. For us in Chem 20, the most commonly used indicator is a chemical known as phenolphthalein. The chemical in the burette, the titrant, we know its volume. We just measured it out, and it has a known concentration as well. The sample has a known volume because we would have measured it out. However, it has an unknown concentration. So, titration sets up like this, and we're always trying to determine the concentration of the sample. In terms of just the vocabulary, we always say that the sample is titrated with the titrant, and that happens until a color change occurs. We have an indicator down here. We're opening this valve and adding titrant to the sample until the indicator changes color, until it just changes color, until there's a faint but permanent color change in the indicator. Phenolphthalein most commonly goes from colorless to pink. Because it represents an experiment, in an experiment we would always perform multiple trials. What we're always going to do is calculate, find the average. X bar, that's the symbol for average. We're going to find the average of the volume of titrant added from 3 good trials. If we were doing this in real life, we would be adding titrants to the sample, looking for the color change. What we would want is 3 consistent results. Any outliers would be omitted. On paper, what this means in practical terms is if we happen to see 4 trials listed, we're going to omit trial number 1. We're never going to omit the second trial. The second trial is never the bad one. The bad trial is always going to be the first trial when we encounter these questions on paper. And then we'll take the 3 good trials, trial number 2, trial number 3, and trial number 4, and average them. Find the average volume of the 3 good trials. Because this experiment is really narrowly defined, where here we know the volume and the concentration, here we know the volume, but we're looking for the concentration, the stoichiometry of it is always the same. After we balance the equation and interpret the question, we're always going to find moles by doing C times V. We're always going to multiply by R over G. And because by definition, we're looking for concentration, we're always going to divide by the volume in the end. When we do a solution stoichiometry problem of the titration style, the math is always the same. The unknown concentration is C times V, with the volume changed into liters, multiplied by R over G, divided by the volume of the sample. The first C and V that we know come from the titrant. The volume over here is always the volume of the sample, and that's going to give us the concentration. In addition, because we're finding the average of the titrant, That average, those 3 trials added together, divide by 3, find the average, is always this V. I've posted a video that also shows the color change itself. That's something to check out, and I hope that helps.